Welcome to the second session on the numericals on the stopping sight distance. So we have the second numerical. The statement of the numerical is as follows. Calculate the minimum distance required to avoid a head-on collision of two cars approaching from the opposite directions at 90 and 60 kilometers per hour. Assume the reaction time of 2.5 seconds, the coefficient of friction of 0.7 and a brake efficiency of 50% in either case. So we'll see the solution. So we have been given with the two cars traveling at a dead speed of 90 and 60 kilometers per hour. And the reaction time of the driver, it is 2.5 seconds with the coefficient of friction being 0.7. But here we have a condition that the brake efficiency is of 50% for both the cars. So we'll find the stopping sight distance using the formula as stopping sight distance equals to velocity into time t multiplied by v square upon 2g f. Here velocity given it is in kilometers per hour. So first we'll convert it into meters per second. So 90 divided by 3.6, that will be equals to 25 meters per second. Whereas the velocity for the second car, that is 60 kilometers per hour, it will be 16.67 meters per second. Now, as we are given the condition regarding the brake efficiency of 50%, thus the wheels, they will skid for 50% of the braking distance and they will rotate through the remaining distance. Therefore, the value of the coefficient of friction developed, that is F, may be taken as 50% of the given coefficient of friction. That means once the brakes are being applied, the brake efficiency will be of 50%. That means the car, it will still move certain distance further. Hence, the coefficient of friction has to be taken as 50%. So 0.5 multiplied by 0.7, that is the coefficient of friction which is being given to us. Hence F, or the coefficient of friction effective, it will be 0.35. Now the stopping sight distance for the first car, that is SD1, it will be equals to V into reaction time t plus V square upon 2gf, where g is acceleration due to gravity and that is 9.8 meters per second square. Substituting the values for the car 1, we get V, as we know, it is 25, reaction time t, it is 2.5, plus 25 square upon 2 into 9.8 multiplied by 0.35. That is the stopping sight distance for the car 1, it is 153.6 meters. Now for the second car, the stopping sight distance, again using the formula Vt plus V square upon 2gf, substituting the values, V as 16.67, reaction time t 2.5 plus 16.67 square upon 2 into 9.8 multiplied by 0.35. So the stopping sight distance for car 2, it is 82.2 meters. Now here, in order to get the sight distance to avoid the head-on collision of the two cars approaching each other from the two opposite directions, so the total stopping sight distance which will avoid the collision, it will be the stopping sight distance for car 1 plus the stopping sight distance for car 2, that is 153.6 plus 82.2 that equals to the total stopping site distance will be 235.8 meters. So this is one more type of a numerical on the stopping site distance. We'll solve one more numerical. So this is the third numerical on the site distances. So the statement for the numerical is as follows. Calculate the values of first the headlight sight distance, and second is the intermediate sight distance for a highway with a design speed of 65 kilometers per hour. So the design speed given, it is 65 kilometers per hour, and we'll have to assume the suitable data. So given is the velocity of 65 kilometers per hour, we'll assume the friction coefficient of friction F as 0.36 and reaction time of the driver T as 2.5 seconds. So in the first case, to calculate the headlight sight distance, so that will be equals to 0.278 V into T plus V square upon 254 F. As you can recall, this is the formula to calculate this stopping sight distance when the velocity given, it is in kilometers per hour. Substituting the values, we get 0.278 multiplied by 65 multiplied by reaction time T, that is 2.5, plus 65 square upon 254 into 0.36, that is the coefficient of friction. So we get the stopping sight distance, that is in this case, that is the headlight sight distance of 91.4 meters. And next we'll have to calculate the intermediate sight distance. So intermediate sight distance, as we know, it is to be taken as twice the stopping sight distance. Hence 2 multiplied by 91.4, that is the stopping sight distance. So we get the intermediate sight distance as 182.8 meters. I hope you must have understood all the three numericals. For better understanding, I think you should solve more numericals so that the concept will be clear. So we shall stop. Thank you.